Hey, how's it going, Math 1? I wanted to go over this assignment, parallel lines using slope. And I believe the main idea is that it's easier to draw parallel lines when you know the equation and you know that the slopes are the same. And so this first section here has you graphing parallel lines just from looking at a picture without any grids or anything. And so in those 100 attempts, it looks like, let's see, how many people? Three times. Three times there was a perfect parallel line. And so here it asks you what would make it easier, and many of you wrote a graph or a ruler, um, grids, a lot of good ideas. The angles, let me see. Another good one was grid snap. That's pretty a pretty good idea because you're going to be able to get those perfect points that you're looking for. Okay, so with that, let's look at when you were given grids, and I can see a lot of you were a lot more successful drawing those parallel lines. And so looking at the data, it looks like 17 times students were able to draw the parallel lines successfully using the grid. So from 3 to 17, that's a improvement just from looking at the grids. So the next thing is looking at the slopes, which is the coefficient, the numbers in front of the variable. So this slope, this coefficient is negative 1.5. This one is negative 1.4. So a lot of you wrote that those are basically close, really close to being the same. And so that's really good. You can definitely see a lot of you focusing on that. Now, if you were to make them the same, they would actually be parallel, the negative 1.5. And so a lot of you got the negative 1.5. It looks like I want to say negative 1.5 and negative 1.4 are so close to being parallel, but they're not. So they definitely both need to be negative 1.5. I believe the directions were to say that it needs to be parallel to this. So you definitely want negative 1.5 on this one here. Negative 1.5 x minus 2. All right, so the next section deals with different equations and making the lines parallel. So I'm gonna basically click on individual answers. So let's see. Okay, so this student was able to get a few, this parallel, this parallel. Let me move this here. Can I move this out of the way? Okay, so now instead of the picture, I'm gonna look at the equations. So this and this are exactly the same. In order for it to be parallel, you need to put plus or minus something that's different than this one. Yeah, this is a good catch. Look at that. The order of the numbers, the terms were different. In this case, the slope was written second. So you would, make sure that the number in front of the x is the same. So that's really good. Let's look at another example. Okay, so yeah, very good. This is the exact same thing. This is a little bit different than the last one, but still the slopes are the same. The y-intercepts are different, so that's really good. Let's look at one more. Okay, so these are all parallel. All right, so let's go ahead and move on to the next. But the main thing about this is that the coefficients are the same, and then you had to have a different number as your y-intercept, and that will make sure that all the lines are parallel. All right, so the final result is that when you have the equations, you're going to be able to get a lot more accuracy, a lot more accurate in terms of drawing the lines perfectly parallel. And so 24 times students were able to make perfectly parallel lines compared to one, only 3 in the beginning where there were no grids, up to 17 where there were grids, up to 24 where you have knowledge of what the slope requirements are for parallel lines. So that's really good. Okay, and then so the reflection, what do they have to be in order to, they have to have the same slope, and I think the last one is the benefits, advantages, and disadvantages for each of these. So when you have no grid, no advantage grids, you can actually see what the slopes are, equations, it's parallel. Okay. The student said that the grids are the hardest one. Um, equations is the easiest. You're just eyeballing everything with no grid. You can see the points with the grid, and then you can look at the equations. Okay, focusing on the points. No grids, it's harder to drag the points. With grids, it's easier, and then you get more accurate with the equations. Okay, well, I think I'm done going over this activity. Make sure you watch the video on perpendicular lines because instead of the slopes being the same, it's going to be different. Different type of thing you're going to do with the slopes. But once you watch the video, then you can look at the next Desmos activity, and then we'll be able to discuss what the slopes are for perpendicular lines. All right, you guys. So keep up the good work, and I'll see you on Google Classroom.